Alright, hello everyone, this is Mr. Crozier. I'm going to go over how to graph an absolute value function. So right here we have one to graph. It is absolute value. So just by absolute value, we know what the graph is going to look like. When we come down here and graph it, it's going to be some sort of letter V that's going to be transformed. So let's figure out these transformations. Well, step number one is to put it in standard form, which means we don't want a coefficient for x. So right now we have a 3 here. So we need to factor that 3 out to the front. So if I divide these both by 3 and multiply that out, so now I have y is equal to 6. Absolute value of x, 9 divided by 3 is just 3, minus 2. So there you have the standard form. Now let's double check that. 2 times 3 is 6, 2 times 9 is 18, and 6 times 3 is 18. So everything checks out with the form. And what that does is it helps us identify the h and the k, which are your vertex. This is the h value, this is the k value. Now this says h is, or minus h, and this is plus h. So we need to take the opposite here, which is negative 3. And this says plus k, and this is minus 2, so again, opposite minus 2 is going down 2. So we have the vertex at negative 3, negative 2. All right, so now let's work on the intercepts. Whenever I think of intercepts, what I think of is x is going to be 0 and y is going to be 0. And what are the corresponding values? So this one's easy, 0. Let's plug 0 in here. 0 plus 3 is 3. Absolute value of 3 is 3. 3 times 6 is 18. Minus 2 is 16. Now the y value usually takes a little bit more work. So we're going to plug 0 in for y. So I have 0 equals 6. X plus 3 minus 2. Add the 2 over. Okay. Divide by the 6. That's 1/3. And now here we get to a point where sometimes we're not sure what to do. Well, whenever we have the absolute value, remember that the absolute value, let's just pick a number of negative 7, turns into 7, and the absolute value of 7 also turns into 7. So there's always two options for an absolute value. X plus 3, this thing could equal a positive 1/3, or it could equal a negative 1/3. So from this absolute value, we have two paths that we have to follow. And if I solve this one, subtract the 3 over there, I have x is equal to negative 2 2/3. That's x is equal to negative 8/3. And subtract 3 over here, so x is equal to negative 3 1/3. X is equal to negative 10/3. So actually what I found is I have two y-intercepts, and that happens. I have 10/3 and 8/3. Because there's two paths there, so you have to be careful in absolute value. You have to follow two paths and see what you get. Alright, so let's do our additional points. Well, if we have the vertex, I always put that in my table. And there it is. And then I always just add one this way, and add another one, and then subtract one, and then subtract another one, and then I just do these points. Negative 2. Plug negative 2 in there. Negative 2 plus 3 is 1. Absolute value is 1 times 6 is 6. Minus 2 is 4. And these are the same distance. And an absolute value graph is symmetrical about the axis, or about the axis of symmetry about this vertex. So that 4 can come down here. And plug in a negative 1. That's negative 1 plus 3 is 2. 12 minus 2 is 10. And there you go. All right, now we have to graph these points. Well, we have this set of data and this set of data, all of these points. And if you notice, for the inputs, the domain, I have all negative. So look how I set up my graph. I only have the negative numbers here. And then if you look at the range, the y values on the other side, all I have, it goes down to negative 2, but then it goes all the way up to 16. So I put a negative 2 down here, and I just counted by 2s. So now I just have to plot these points. And it's probably easiest to start right here. Negative 3, 2. Negative 3, 2 is there. And these are good points too. Negative 2, 4. Negative 2, 4, there's a point. Negative 4, 4. How about negative 110? negative 510, and might as well plot this x-intercept, or y-intercept, sorry, y-axis, x-axis, 0, 16, 2, there. And what about these? Well, these have taken care of themselves. If I go ahead and draw this line here, looks like that, and looks like that. Those 2 points are going to be negative 2 and 2/3 and negative 3 and 1/3. So I've gotten all 8 points plotted on my graph. And there's a graph. If you want to check it, you can use Desmos, or you can use a calculator, graphing calculator. If you hit y equals, you can type this in. Let's go back to the original. 2, to get absolute value, you hit math, number, ABS for absolute value, 3x plus 9 minus 2, graph. Graphs it in standard form. If you want to make it match what we just graphed here, let's change the window. Let's go from about a negative 5 to a positive 1, counting by ones, and let's go from a negative 4 to a 20, counting by 2, and there you'll have a closer picture of what we just drew right there. All right, hope this helps. Graphing absolute value functions.